You ever look at something like a crystal or even just a cardboard box and wonder if there's some kind of hidden rule connecting them? Well, it turns out there is. And today, we're going to crack the code and uncover one of the coolest secrets in all of math.
Okay, so just look at these shapes. You've got your cube, your pyramid, a prism. I mean, they look totally different, right? But what if I told you they're all secretly following the exact same rule? And it's a super simple one. That's the mystery we're digging into today.
All right, so to crack this thing, we need to know what we're looking for. We can't just throw any 3D object into the mix. Nope. We have to focus on a very specific, kind of special group of shapes.
And that special group? They're called polyhedra. Yeah, it's a bit of a mouthful, but the idea is actually super simple. A polyhedra is just any 3D shape that's made up of totally flat surfaces, or faces. There's really only one major rule. Absolutely no curves allowed.
So yeah, that's the big difference right there. You've got two teams. Team polyhedra, all flat faces, all straight edges. And then you have team curve, things like spheres, cones, you get the picture. For what we're doing today, we are 100% on team polyhedra.
And this really makes it crystal clear. Over on the left, you see our main suspects, the polyhedra, the cube, the prism, the pyramid, all nice and flat. And on the right, the rule breakers, your sphere, your cylinder, your cone. They're cool shapes for sure, but all those curves mean they're not part of this particular puzzle.
Okay, so we've rounded up our suspects. Now we need to learn how to talk about them. You know, like a detective breaking down a case, we need to understand the anatomy of these shapes. And it really just comes down to three key parts we need to look for.
First things first, faces. We'll just call them F for short. These are literally just the flat surfaces of the shape. Super easy. Think of a die. It's got 6 sides, right? Those are its 6 faces. So let's use this pyramid as our example. See that? It's got one square face on the bottom, and then 4 triangle-shaped faces that all meet up at the top. You add them up, that's 5 faces in total. So for this guy, F is 5. Easy enough?
Next up, we've got vertices. We'll call these V. And again, it sounds fancy, but it's not. Vertices is just the math word for the corners. You know, the pointy bits where all the edges meet. Let's stick with our pyramid here. It's easy to just count the corners. You've got the 4 on the bottom, and then that one sharp point right at the top. So for our pyramid, that means V equals 5. And the last piece of the puzzle is edges. We'll call them E. Edges are just the lines where any two faces come together. They're kind of like the skeleton of the whole shape. All right, one last time with our pyramid. Let's count them up. We've got 4 edges around the square base, and then 4 more that slope up to that top point. 4 plus 4 gives us a grand total of 8 edges. So E is 8.
All right, so now we have our 3 tools: faces, vertices, and edges. F, V, and E. Now that we know what to count, the real detective work can finally start. Let's get some data on the board and see if we can hunt down this hidden pattern.
Okay, let's start logging our evidence. We'll start with a classic cube. A cube has 6 faces, 8 vertices, and 12 edges. Got it. And we already did the pyramid, right? That was 5 faces, 5 vertices, and 8 edges. Let's get those numbers up there so we can see them side by side.
Okay, just take a second, look at those numbers. For the cube, you have 6, 8, and 12. For the pyramid, you have 5, 5, and 8. Is there some way you can add or subtract those 3 numbers in each row to get the exact same answer for both shapes? Now, if you figured it out, that is awesome. But if not, don't sweat it. Seriously, because for literally centuries, nobody saw this pattern. It was just hiding in plain sight until this absolute genius mathematician, Leonhard Euler, came along and just blew everybody's mind with how simple it was. And here it is. This is the secret formula, the secret code. For any simple polyhedron, you take the number of faces, you add the number of vertices, and then you subtract the number of edges. And the answer is always 2. That's it. It's not some crazy, complicated equation. It's just the number 2. It's so simple, but it's incredibly powerful. It doesn't matter how big or small the shape is or how complicated it looks. As long as it's a polyhedron, the answer is always 2. But hey, don't just take my word for it. Let's put it to the test. For our cube, 6 plus 8 is 14. Minus 12 equals 2. It works. Okay, what about a triangular prism? 5 plus 6 is 11. Minus 9 is 2. Check. A pentagonal prism. 7 plus 10 is 17, minus 15 is 2. See? It just keeps working every single time.
Now, here's where things get really cool. This 3D rule actually has a deep connection to the 2D world. So imagine for a second that you could take one of these shapes, maybe cut it carefully along some of its edges, and then just unfold it and lay it flat. What do you think you'd get? What you'd get is something called a net. And a net is basically the 2D blueprint for a 3D shape. It's the flat pattern that shows you exactly how all the faces connect together before you fold them all up.
And here's a perfect example. You see the 3D box on the left, right? And then on the right, that's its net, all 6 of its faces unfolded and laid out completely flat. It's such a cool way to see that connection between a 3D object and its 2D pattern.
You know, if there's one big idea to walk away with today, it's this. Math isn't just about memorizing a bunch of boring rules. It's really about being a detective. It's about looking at the world around you and finding these amazing hidden patterns that tie everything together. So, we've totally proven that for any of these simple shapes, faces plus vertices minus edges equals 2. But that brings up a really interesting question. What happens if the shape isn't so simple? What if it has a hole going through it, like a donut? Does the formula still work? Well, it turns out that little hole, it changes everything. But that's a whole other mystery for another day.